Bigelow more than me.
Okay.
Bigelow, 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 Bigelow. You lose, chat.
I'm out.
Hey everybody.
Hello.
Hey, Sergio Patero's here. You should check out his Facebook page. He's designing these really cool images for our my upcoming collaboration with Isaac Arthur, where we talk about mining resources from the solar system. He's designing gas giant scoops and all kinds of cool ideas. So
Sergio, what?
Patero, yeah, he's on the. I was telling the chat that, but you can do that too, or prepare for Astronomy Cast, whatever works for you.
I can do both.
Yeah, I know you can.
Ow.
Oh, that's awesome. Oh, fantastic. Say hello in a
Hi.
second, or I won't say hi to you. Oh, Eddie. Can you show that video again of Eddie? So,
Yeah, look.
Eddie likes to eat ice cubes.
Yeah, it's ridiculously adorable. Oh, I'm in the wrong app. Like he begs and begs for ice cubes.
That
He
is.
just he just wanted a bowl of ice cubes to chomp. It's all he wanted.
And there he is, right there with you.
Always. He's a happy dog.
All right, I'm going to say hi to a bunch of people. I'm going to say hi to Adam Synergy, Arnold Post, Bill K, Bort Clankar, Capital H, Carolyn B, David, Joseph, Wesley, Dusty Reichwin, Ilad Avron, Galaxia, Guido Bibra, Holly Meyer, Ignatiy Romanov, Cherengovsky, James Haney, John Seffield, Quod Libe. Oh, I have a tough one with this. Quad Libet. K Wad, I bet. K Wad, I bet. K Wad, I bet. Anyway, Larry Beckham, Lillian Brennan, Malcolm Ford, Nancy Graziano, Navi Ferry 64, Paul Dizzy, Peter Quinn, Refurio Anacro, Sergio Botero, Steve Heistand, Stir Fry Kitty, Tom Van Scotter. Hey,
I
everybody.
still love the stir fry kitty name.
Hello, everybody, and welcome to this week's Astronomy Cast. If you're wondering what on earth it is that you have stumbled into, we are going to do a live episode of Astronomy Cast. We will take a random amount of time to actually do the episode, depending on when I decide that I have learned enough. And then we will switch and we will take some time and answer your questions about space and astronomy. Feel free to talk about what we talk about in the show, or feel free to ask Pamela any question that you like. Complexity should be no obstacle. Stump her.
It happens a lot.
What else was I gonna say? Nope, that's it. All right.
Okay.
John Suffield says, "You like the name? Now try the meal." Stir fry
No,
kitty.
no, I will have stir fry. No, I wouldn't even eat stir fry. I have stuff selected by kitty. That's probably even worse.
Great. Are you ready to record?
Yeah, I just need to silence my phone. Silence.
Yeah.
Oh, so you guys got lucky on this one because it was supposed to be a logistical nightmare because I was supposed to go from giving a talk at a conference to dashing to find someplace to record. And instead, I got really sick and couldn't get on the airplane yesterday. So my suffering allowed you to have an easier show.
And we got to mention that survey, right?
Yep. And I have the link now.
Yeah, I see it there. Survey.libsyn.com/astronomycast.
Yep.
Okay.
I am ready to record if you're ready to record.
I am also ready. Oh,
You have a new world, or your camera angle changed.
What? No?
Did you add Mars, or did you adjust your camera angle?
You see something different than the audience sees.
Okay,
Yeah.
never mind.
Yeah. So don't worry about it. You have a different camera. You have this one.
Okay.
There, enjoy. That's not helpful. There you go. All right. Right. What were we doing? We were going to create an episode of Astronomy Cast. This show is lame. Let us begin.
I'm pressing record.
I am also pressing record.
Hi,
I am
Chad.
recording. Hi, Chad. Astronomy Cast, episode 450, Inflatable Habitats. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing okay. How are you doing?
Great. Survey.
Okay. So as we mentioned in the last episode, we have been hosted forever, by which I mean for like 10 years, almost 11 years on Libsyn Media. And they've taken care of us, and they've asked if we could ask you to do a survey. And since they've been so good to us, please go fill out the survey. It's survey.libsyn with a Y, because they think the way I do. Libsyn.com slash astronomycast. So survey.libsyn, LIBSYN.com/astronomycast. Please take their survey, please. We'll put it in the show notes.
These kinds of surveys are super important for us as creators to be able to get a sense of just who our listeners are, what they want to hear, where they come from, what audiences. Very important. So please. All right, let's get on with this episode. In order to live in space, we will need to live in a habitat that simulates the temperature, pressure, and atmosphere of Earth. And one of the most interesting ideas for how to do this will be with inflatable habitats. In fact, there are a few habitats in the works right now, including one attached to the International Space Station. Oh, and before we get into the show, I forgot to mention big thanks to a couple of our patrons who came on board. Dusty Reichwin, Kenneth Ryan, and Sylvan Westby. Thank you so much for becoming patrons of Astronomy Cast. Patreon.com/AstronomyCast. All right.
And Dusty Rushwin, we still love your avatar photo. It's awesome.
Please continue now, Pamela. Sorry, Chad, you may have to do some editing there.
Do you just want to like restart?
Well, let me do the intro. Let me restart. You said, you know what we're gonna do? Well, don't worry, we don't need to restart. We're gonna get to the part where you talked about the
survey. I finished the survey.
Yep. And then I'm going to say, I'll
how
thank the
important
patrons.
Surveys are.
Yeah. Well, no, after we're done all that. All
okay.
Right, so here we go.
Sorry, Chad.
So Chad, so just after the survey part, put this in and then we'll go into the intro.
And all of you listening to the raw, just mock us.
Yes,
This is why we put out the edited version.
Brutally, yeah. A big thanks to our patrons this week. A big thanks to Dusty Reichwin, Kenneth Ryan, and Sylvan Westby. Of course, you can support Astronomy Cast by going to patreon.com/astronomycast. Let's get on with the show. In order to live in space, we'll need to live in a habitat that simulates the temperature, pressure, and atmosphere of Earth. And one of the most interesting ideas for how to do this will be with inflatable habitats. In fact, there are a few habitats in the works right now, including one attached to the International Space Station. So, Pamela, I'm working on an episode of The Guide to Space all about Wernher von Braun's plans to colonize Mars. He wrote a book called The Mars Project, or Das Mars Project, in 1948, and it's just terrible. He was not a great fiction writer. But the appendix that's attached to this book is phenomenal and goes into incredible detail. And a lot of the ideas that he had are sort of have been playing out ever since. And sort of one of these ideas that he actually proposed, like literally back in the 40s, is this idea of inflatable habitats, that they would send that first crew to Mars. They would set up an inflatable habitat on the surface of Mars and use that to protect themselves from, I don't know, the Martians. They,
As you do, as you do.
well, Martians could get into the inflatable habitat, into your habitat, and eat your stuff. So now, so this idea has been around. What I'm saying is this idea has been around for a long time, 50 plus years. Can you, give us sort of what is the requirement for such a habitat? Why do we need these things in the first place?
Well, clearly you need to protect yourself from the Martians
Yeah,
eating your food.
yeah.
That may be one of my favorite things you've ever said.
They built these canals, and the canals have run out of water, and now those poor Martians were thirsty and starving, and they need to get into your habitat and eat your food.
Okay. So reality is far less amusing. I mean, primarily you need the inflatable habitat to do three things. First of all, it needs to fit into the area of a rocket ship that will get it into space. And inflatable things start small, think balloon, and then get really big. This is useful for fitting things into rockets. Once you get them into space, which is the first criteria of them being useful, because if you can't get them off the planet, they're not useful. Once you get them into space, they need to protect you from everything outside of the habitat. So they need to protect you from micrometeorites, they need to protect you from radiation. And then they also have to keep you and everything in the habitat okay. So this means they can't be leaking their oxygen. They need to be nice and stable and stay together and hold their shape and all of the things that keep you alive.
Right. And so, you already sort of mentioned what is really one of the main advantages of an inflatable habitat versus a rigid habitat is volume compared to what you can put on a rocket, right?
Right. So the awesomeness of this is you can start with something that isn't too big a deal, fits easily in an Atlas V fairing, and then becomes 330 cubic meters.
Can you give us some kind of comparison to like what the International Space Station, like what, how many what modules would contain?
That would require me to know the names of modules. The way to think of this is you start out with something that would easily fit inside of a school bus, and then it gets much, 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 much bigger.
According to the internets, the ISS has the internal volume of a Boeing 747.
Okay.
Yeah.
So that includes all the different modules.
Yeah, that's been put up so far.
Yeah. And
32,333 cubic feet, which, 935 cubic meters.
So with these, it's useful because while they don't pack up as nicely as like a tent might, it's a similar principle. Everything squishes down into a little bag, and you're not quite sure how the manufacturer originally got it into that bag because it's never going back into it ever again. But when you take it out of the bag, you end up with this giant room that is easy for you and several of your friends to live within.
Now, what are the downsides of having an inflatable habitat?
Kind of cool that way. So one of the awesome things is people have been like really worried that with the inflatables, for instance, you won't be able to get the same radiation protection that you get with the metal hull that they build on spaceships. Except it was realized that certain vinyls that are rich in hydrogen atoms are actually just as good, if not better, at protecting you from certain forms of radiation. And they also don't scatter the radiation the same way that you have to worry about with metal. So you don't end up with the same reflections, for instance. So radiation can cope. When it comes to micrometeorites, they're actually a lot better than the aluminum, because an aluminum layer is rigid. You hit it hard, it dense. We've all probably had rocks fly up and hit the hood of a vehicle we were familiar with, and you know that dent that it leaves. Well, that rock is going nowhere near as fast as the stuff that hits the space station. And periodically things try to enter the space station this way. Rigid just doesn't quite let you in. Or sorry, just doesn't quite protect you the same way from letting this stuff in. The inflatables actually have multiple levels of materials, and it will squish down and give a little. And this process of giving a little can slow down the micrometeorite over a distance. Slowing it down over a distance means that it is able to exert far less of an impact onto the surface. And it's not gonna get punctured the same way the aluminum would.
So that is not a downside. That is an
No.
upside.
Mm-hmm.
So let's talk about some of the inflatable habitats that are in the works or actually deployed right now. And if we had done this show back at the beginning of Astronomy Cast,
Which we tried to do,
this all would have been theoretical. But now here we are, 10 years later, we can talk about actual, practical, physical, inflatable habitats that are up there in space right now.
So Bigelow Aerospace.
That's one. The chat has wants to find out how many times we're going to say Bigelow during this episode. Bigelow Aerospace. This is not an advertiser of this episode of Astronomy Cast, and yet enjoy the sponsorship.
It's true. It's true. So
the promotion.
Oh man, now I'm like trying to figure out how to phrase these sentences to like how few times can I say it?
No, don't. Just give in.
So folks have long been thinking, let's use inflatables for all the obvious reasons. Think tents, like I said before. And the folks over at Bigelow Aerospace, which is of course led by Richard Bigelow, or Robert Bigelow. Sorry,
Yep.
It's Richard Branson, Robert Bigelow. Yep. They're consistent on the initials. Robert Bigelow have been working on actually making these a practical reality since the early 2000s, and their biggest hurdle has actually just been being able to get these things into space. They launched their first two test modules. This is Genesis 1 and 2 on the Russian Dnepr.
Yep.
Do you know how to say? Yeah,
Dnepr. You're the one who speaks Russian.
I know, but it's not written in Russian. So have launched them on Russian rockets. They went up in 2006 and 2007, respectively. And they basically went up to prove the concept, to figure out, can we do this? They were each 11.5 cubic meters, so an uncomfortably small space, unless you like those compartment hotel rooms that you can sometimes get at airports. But the uncomfortably small space was used to test insects and equipment. They ran advertisements on the insides of these things. They just wanted to figure out, does this work? And the answer was yes. Yes, it worked. They were then working on something called Galaxy. It was going to be a little bit bigger. They ended up canceling that after doing tests on the ground with it, and jumped to instead working on the, I'm going to say it again, Bigelow Expandable Activity Module, which is otherwise BEAM.
BEAM, that's the last time you need to say that. BEAM.
So the BEAM module, which is a fabulously forced acronym, is something that launched on a SpaceX on one of the Dragon rockets. It was built under NASA contract for only $18 million, which, if you think about things for outer space, that's like free.
Yeah, they find that in the couches.
Right. So a $18 million, that's multiple years of funding for a whole, it's free. So they built this great little module, 16 cubic meters. So if you think about that, it's still tiny. It's still like a tent you'd go camping in. But they hooked it up in the summer of 2016 to the International Space Station. First time they tried to blow it up, it said no. Again, kind of like expanding your tent. Second time they went to expand it out, worked perfectly. And it's been there ever since. And every few months, the astronauts go in and they go, space, I have space. It's lots of space. It's awesome. And then sadly, they go back into the rest of the ISS because they're not allowed to live in it yet because it's there for testing purposes. But they're currently monitoring what are the radiation levels inside, just to double check that all of the theoretical understanding was correct. They're checking, does it develop leaks? All of these things that have to be tested before astronauts are allowed to live in things are getting tested. And so far, it's going beautifully, and it's awesome.
Yeah, and I mean, just to really kind of set the stage here, right? That as you say, a module for the International Space Station that has as much living space in it as any other module. It's got 16 cubic meters. So it's not a lot of space in there, but there is some space. Was built for $18 million. Was launched as part of a SpaceX launch and then was attached and inflated. This is amazing, and this is just the beginning. So let's talk about some of the future, much larger inflatable habitats that are in the works.
What I love is they actually have a full-scale mock-up of what they're calling Space Complex Alpha, because it needed to sound Star Trekky. That is the best
name.
Of course. So they're working on Space Complex Alpha, which is 3 different blow-upables with solar arrays that are mounted in the center against an airlock, and these 3 inflatables are what they call their B330 modules. Now, can you guess why they might be called B330s?
Is that the amount of volume?
Yeah.
330 cubic meters? Yep.
Just keep it nice and simple. And so they're Nautilus B330s is what they're calling them. Are going to be an easy peasy way of basically, with 3 launches and however long it takes to get the airlock up, having a giant space station that is close to free again. And the issue that they're running into is they just need the launches, because they actually have big plans for something they're calling the Olympus, which is a BA 2100 for yes,
2,100 cubic meters. Is it cubic meters or cubic feet? No, it's cubic
meters.
Yeah, it's cubic meters. So now let's talk about the Olympus 2100. What will it take to put that into space?
Sadly, it's going to take SLS's heavy lift vehicle actually getting like fully put together and having available launches. And that's something that's currently just not in the cards. SLS has very, very few launches scheduled. And so while this thing could go up, shouldn't be too hard for them to build given everything else they've done. We don't currently have a working rocket it could fly on. And
right. I mean, it's going to weigh between 70 to 90 tons. So you're going to need, as you said, the SLS. You're going to need a Falcon Heavy. You're going to need the...
It's too big for the Falcon Heavy.
Is it really? Oh, okay.
Yeah.
So maybe they should make it a little smaller and fit on a Falcon Heavy.
Well, this is why they have their BA 330s. Just keep plugging them together.
Yeah. Yeah, exactly. So now, are these going to be attached to the International Space Station, or are these going to be standalone machines?
They're looking to be standalone. And this is another one of the things that's holding us up is Bigelow for a while was playing with having its own launch vehicles, but really they make inflatables. They make tents for outer space. And without having launch vehicles, they're on the ground. So currently they could launch on Dragon, they could launch on a Russian rocket. But what we don't have is a human certified commercial way to get tourists into space other than the very expensive Russians. And with the Russians, you're looking at tens of $1 million per human to get into outer space. And that's not a good way to spend one night in a hotel.
Right, right. And this is the sort of the con. I mean, this is what Bigelow is really hoping for, is to develop an orbital hotel, a station, at 2100, right? It'll have twice the volume of the current International Space Station delivered on one rocket, and then it will just inflate.
Yeah, it's kind of awesome.
Yeah.
So what their hope is to eventually get to the stage that it will be $1 million for one night in their on-orbit hotel, or fairly reasonable numbers, cheaper than the flight up on a Russian spacecraft, to rent out like half a module or even perhaps an entire module. So this starts to get interesting, where you can imagine not just like the rich uber one percenters going and spending the night in space, but you start to be able to imagine like a university considering, instead of spending $18 million building another Hobby Eberly telescope, instead putting a bunch of scientists on a commercial inflatable for a little while.
Yeah. That's kind of crazy.
What it does to the price is just absolutely phenomenal. And it also starts to make other things look possible. So we are looking at ideas for doing inflatable habitats when you get to Mars. Partially bury that sucker and then blow it up, but like inflate it, don't explode it.
Don't blow it up.
Yeah. And
the moon.
It makes the moon, all of these things. If you don't have to take things that are solid and you can just stuff them in the bottom of your rocket ship, I mean, this is like everything they tell a traveler to do. These things do. You don't want to pack solid empty objects. Who wants to do that? But that's what they did with the ISS. Sorry, I'm about to go into rant mode as someone who travels frequently. This is just such an obvious thing to do. And we just haven't gotten it human certified yet. But that's what they're doing. They're human certifying it. And I'm going to stop being overly enthusiastic now.
Right. And so, but I mean, I think the future of human habitation modules in space is going to be these inflatable modules. The costs are so cheap. The ability to have something that is small and then have it inflate on orbit to create a much larger volume. As you said, the potentially increased levels of protection that you can get from it. There's a lot of really good reasons to go with this inflatable concept. And you could theoretically take more, have them, not inflated, and then as your space expands, just inflate another module and fill it up and get it ready and prepared. So I do really feel like a big chunk of the future is going to be these inflatable habitats. I mean, kudos to Robert Bigelow and team. They've gone through a pretty rough time. I mean, they have been planning this as long as I've been reporting on space exploration, right? And I've been doing this for almost 18 years, right?
But they're one of the sleeper heroes. Like,
absolutely.
Everyone knows about Elon Musk. Everyone knows about the Amazon dude. And we know the rich geniuses that are loud.
Yeah. Yeah.
Bigelow is quietly going through doing all the steps. Genesis 1 flew,
Yeah.
worked. Genesis 2 flew, worked.
Yeah.
Their beam is working.
Yeah. Yeah. And it is feasible to take a much larger module, attach it to the space. And I remember Bigelow went through some pretty tough times I guess about 10 years ago, and they weren't expecting they were expecting launches to be happening before they did, and they had to lay off a big chunk of their workforce, but they didn't go under. They kept going. So I think you're exactly right. It's sort of one of the less mentioned heroes of this whole sort of space age. And I'll bet as we look into the future, we're going to see a ton of the habitats in the future made with this inflatable module. What are some of the other, I guess, technological developments that would take this to the next level? I mean, there's radiation protection. Are there ways that we can sort of use, get help in that area as well?
So this is where the materials designers and thin film experts out there really come into play. The idea that we can start looking at what aspects of a material make it good radiation shielding, and at the atomic level think through what do we need to do to make thin, light, radioactive particle protecting cloth. This is a new way of thinking. And while it's still not something that you can simply put on a skin suit and you're protected from radiation, it's getting to the point where you now just have multiple layers of materials that each protect against something slightly different that is too cumbersome to wear, but not too cumbersome to live within. We still have a ways to go before we're ready to go to Mars. But this new way of thinking is really kind of exciting, where you're starting to think of what can I do with Kevlar and Mylar and vinyl,
Mm-hmm.
and how many hydrogen atoms can I cram into this artificial synthetic material?
Well, and start to create layers, right? So you could have multiple
Mm-hmm.
layers, and you could even do things like put water in between the outer layer and the inner layer, and then you've got the inflatable part inside. And water is one of the best forms of radiation protection. So we've really just begun to figure out what are the potential applications and how you can build those layers. And we may end up at this place where it's this standard set of layers that are always launched and they're always used, and they've got the right Kevlar, they've got the right Mylar, they've got the right, a place for the water, some kind of radiation protection, built-in plumbing and circuitry and all that kind of stuff. And that's just, it's a standard thing. And you launch it to space and you get inside. I imagine astronauts in giant inflatable hamster balls bouncing around on the surface of the moon. They don't have to put on a spacesuit. They just bounce around inside this ball.
Hamster balls,
Yeah.
yeah. That is actually truly delightful if you've ever seen any of the videos of people like rolling down hills in
Yeah,
hamster balls
exactly.
for humans. So
Make
so
them
where
clear.
it does where it does get tricky with these inflatables is because they aren't rigid. When you start filling them with liquid, you have things that jiggle like jello, which leads to all sorts of momentum issues. So we need to be careful and figure out how to make things rigid enough that we don't end up with all sorts of crazy rotations accidentally happening. We need proper support, you might say. But these are solvable issues. And while it may not necessarily be good momentum wise to fill the outer part with a variable layer of a semi-compressible liquid, these are solvable problems.
Just imagine the jiggling. Um,
Astronauts in jello. We're talking about astronauts in jello
yeah,
now.
exactly. All right, well, it's pretty exciting. I cannot wait until this moves forward. Pamela, thank you so much, and we'll talk to you next week.
Sounds great, Fraser. Talk to you later. And now we save.
Save. Save that. Episode 450. That's crazy.
We're finishing out our 10th season.
Yeah. What have we got? Let's see, 3 more episodes?
Something like that.
Yeah. I think our last one's on the 15th of June.
I don't remember.
Yeah, we just show up. We don't know what to do.
Susie, we love you. you keep us going, Susie. All hail robot overlords and Susie.
Yeah. Okay, that's the last time I'm going to say Let's get on with some questions. Are you ready?
Wait, hold on. I thought you said 460, but I thought this was 450.
It is 450.
Oh, I misheard you. Never mind. Say.
Elad Avron asks, I know we haven't found any moons around moons. What does the math say? Do the physics even allow for it?
Moons can have moons, but where it gets tricky is the dynamics to do it. So someplace like Jupiter, you can imagine its big moons having tiny things going around them. I don't know how stable it is because that's a 3-body problem, unless so you need to have like a maximally sized planet.
Yep, like a Jupiter.
Jupiter's within a factor of 10 of that.
Yeah.
A large moon. So here you start thinking Ganymede.
Mm-hmm.
And then
you want to have it far away from the planet.
And then you need to have something stably bound to it at near the Roche limit so that it gravitationally is mostly ignoring that planet.
Right. It's in the Hill sphere of the moon and not another planet. The distance.
I don't know why the answers are up here, by the way.
Yeah. The distance is important. We actually did an episode on this, and the research that I could do, it was Neptune could pull it off. So if you had Neptune and you had Triton, you could have a moon around Triton.
Moon.
Yeah. Yeah. So I think that would be, it would be super cool for us to find it. Did you hear that now that 8 out of the 9 largest dwarf planets, or 8 of the 9 dwarf planets in the solar system have moons? They just found a moon for the 3rd largest, 2007.
That's kind of adorable.
OR10. So.
Oh yeah, the one that Megan Schwab keeps refusing to name. Name it, Megan.
Why would she name it?
Well, she can propose a name to the IAU. They can ignore her, but she can try. It needs the name.
Quadlibat says, Fraser Joe, question for you. Works only if you know Pulp Fiction. Do you know what they call a B330 in Europe? I don't know. Tell me what they call it in Europe. Because I
haven't watched that movie in so many years.
Yeah, probably a Royale with cheese. Well, no, it's the opposite, because the B330 is metric. So really, it's what do you call the B330 in the United States? Because they don't know what the metric system is.
I do.
Yeah.
But I'm a scientist.
Holly Meyer asks, on what worlds or moons would the inflatable habitats work? Obviously, gas giants are out of the question right away. Where would the inflatable habitat...
You could totally have an inflatable habitat in the top layers of a gas giant. It's just like anything else. The deeper down you go, the more you get crushed. And if you're in the top layers of the atmosphere, you're going to have a lot of friction deteriorating your orbit. So it's not really an orbit. It's a what can I do to float here buoyancy issue, because orbit's just not going to work. So that was a whole lot of fancy words to say. You can go just about anywhere that you want with an inflatable as long as you maintain the right altitude.
We'll maintain the pressure. Right?
Well,
I think your point, right, is if you sink down further into, say, Jupiter's atmosphere, or maybe you sink down in Venus, which we didn't even... then the pressure is going to push it more closely together. We didn't even talk about how, Venus would be a place where, breathable air is a lifting gas. You could pop one of these into the atmosphere of Venus and have it float around. That would be really cool.
It's a thing.
Navi 64, is there a relationship between the dark matter mass of a galaxy and star formation?
Say that again.
Is there a relationship between the dark matter mass of a galaxy and star formation?
I don't know. I don't think so. I think because the star formation by okay, stepping backwards. Dark matter is related to the total mass of the galaxy and the type of galaxy in a not quite linear way. So like baby dwarf spheroidal galaxies have massive dark matter content. Giant galaxies still have massive, but not as massive proportionally dark matter content. When you start looking at star formation, you see star formation in galaxies that are rich in dust, gas, and it's also structurally relevant to look at. So you see star formation active in galaxies like ours, nice happy spiral galaxies. But then if that nice happy spiral galaxy undergoes an interaction, you'll turn it into a star bursting galaxy as all hell breaks loose. And then all the star formation ends as you turn into something like an elliptical as a result of that interaction.
Awesome. David Joseph Wesley says, I'm only down with inflatable habitats if they make them look like super cool cyberpunk dirigibles. Agreed. That should really be a requirement. They should have brass rivets.
Someone please tweet that.
They should have brass rivets and propellers and yeah, absolutely. Raza Siddiqui, can we build space factory to make the materials that are required in space instead of sending them from Earth?
It depends on what we want. So there's a fair amount of the materials that you need to make ceramics locked up in your average asteroid, but your average asteroid doesn't have a lot of metal, for instance. Metal is not a reason that you want to do asteroid mining in general. You can't really build things out of hydrogen-3 or helium-3. I don't remember which it is at this point on a Friday, which is the gas that they're always after. I'm pretty sure it's helium-3.
Helium-3, yeah.
Okay. So if you want to build ceramics, you can do a lot of ceramics, but all of the nice petroleum stuff that we use to build a lot of the plastics and things like that, you need the processes that led to ancient dead dinosaurs, although they're now starting to think that dead dinosaurs did not become oil because dead dinosaurs are not found in the same places as oil. But that's a different episode.
So I think what you're getting at is that there are really two parts to this problem. One is, are the raw materials to make this happen available in this environment? Some of the things are, like regolith is going to contain the regolith of the moon, or the regolith of an asteroid is going to contain silicon and oxygen and various elements. Metal asteroids are going to have the various kinds of metals that you want. You're going to have access to hydrogen and lithium and all kinds of things like that. But the deeper question is, do we have the manufacturing capability to actually build these in space? When you think about what it takes to make a microchip, to make a phone, right? You take a phone, there's glass, there's plastic, there's metal, there's circuitry, electronics, there's all kinds of things that are inside this thing. And we have, in some cases, massive factories here on Earth where that stuff gets built. It could very well be that in the beginning we can only manufacture certain things, very primitive, like you see these 3D printers that can build habitat on the surface of the moon or Mars by just spraying concrete, right? That's the part that you can build locally, but you still have to bring phones from Earth. Later on, you could imagine vast factories that are able to produce more and more stuff.
And have you read I Am Bob, I Am Legion yet?
No, I haven't. I'll do it. I'll do it.
It's fabulous. You need to. Um, so they have these entire like foundry ships basically that then the foundry ships can replicate themselves, and this idea of the self-replicating all the way down is super useful for thinking about how these things you're 3D printing reality. So you start by building a ship that's capable of processing an asteroid in one side, sorting the elements, and then 3D printing out the other side. So we need to figure out how to sort the making easy 3D printers in space problem.
Yeah. And this is a thousand little advancements that have to happen, both in terms of mining, refining, and construction. And we're going to chip away at it over time. And that is one of the things that you really think about the future of humanity, is that we are going to create self-replicating robotic factories, and we will use them to explore the universe. Can we do them today? No. We couldn't do one on Earth. Could we do one in 200 years, 500 years? Probably, right?
Well, and what's interesting is some of the materials that we're finding can be processed in really fascinating ways. The lunar dust, they realized that if you subject it to the right wavelength of microwave radiation, will melt into a nice ceramic material. So there are crazy folks down, I believe, at the University of Tennessee, and by crazy I mean crazy awesome.
Yeah.
Who have envisioned things like, instead of having a street cleaner with the brushes that clean the street, instead have like moral equivalent vehicle that has microwaves on the bottom that drives along creating the street. And when you start thinking about how can I transform materials using melting as part of the process instead of ingestion, and building up, so subtractive processes instead of additive processes, there's lots of different ways to process these materials. It's just getting that initial foundry ship that's the difficulty.
Yeah. Yep. Gray Rose Tint asks, are Russian rockets better?
They're rockets. They go into space. Any rocket that succeeds in being nominal and getting you into space is a good rocket. I draw the line at, are you nominal? Okay, we're good.
The Russian rockets, the Progress, the Soyuz especially, have been launching almost unchanged for decades and decades and decades. They are reliable. They are tanks. They rarely fail, but they also haven't really been changed and advanced. And while the Americans have gone through a bunch of different kinds of technologies, the Russian versions have just kept flying. That said, I think we're about to move into a new era where there's new technologies, new formats, such as rockets that get reused, that the Russians just don't do. So I think we are reaching the end of that disposable rocket era that the Russians figured out a plan, and they just didn't deviate away from it.
And we're still going to have some rockets that can't come home. So there was the launch a few days ago, I don't remember which day it was, where they were launching the IMARSat, which was a communications satellite that will be used to put further connectivity on aircraft for Wi-Fi, which is near and dear to my heart. And that particular orbit was one with that particularly heavy spacecraft, where there is no way that that first stage was coming home safe. So there's always going to be some orbits that you can't get there from here and come back.
Mm-hmm.
But you reuse a rocket a bunch of times and then kill it off, that's still a huge savings.
Max Sixblade asks, how do you think humanity will be able to make it to another planet, not just put a step on it, but to actually put on some kind of permanent presence? If so, when do you think it may happen? When do you think humanity will have a permanent presence on
That's a
another
money
world?
question. It becomes a question of who is going to invest the funds in building the greenhouses, in figuring out the why tilapia can't be bred successfully in space, because nothing wants to breed in space, as we talked about a few episodes ago. Who is willing to invest the resources in putting down the foundation and raising up the walls instead of just building that tent?
Yeah, there's that sort of like who's going to pay for it and how's it actually going to get done, and part of it is what are the requirements of a fully self-sustained civilization that truly doesn't need Earth for regular supplies. And I think Elon Musk put that number at 1 million people, and that I've seen some other calculations done, and that sounds about right. That you would need to build and that robotic factories would be doing a lot of the heavy lifting. When you think about the society that we live in, not all of the countries on Earth are self-sustained. That there are countries that can't produce enough food or can't produce enough of the various raw materials that they require to live on, that they have to import and export from other places to be able to survive. And Mars is going to be like that. It's really, so for the first large period of time, you're going to have a colony that can't survive without Earth. And then over time, once you hit that $1 million mark and you've got 1 million people mark and you've got these robotic factories and they've worked out systems for everything, then you could very well be. Elon Musk says that we'll see that by the end of the century, that we'll see 1 million people on Mars.
And one of the reasons that number is so high is if you think about it, a few hundred years ago, there were perfectly self-sufficient little villages all over the planet. There are still probably a few happily self-sustaining little villages, unless you want a cardiac specialist, unless you want a neurologist.
Yeah.
And it's because of the high levels of specification and the high levels of education that are required for those specialties, that if you want to be truly self-supporting and not need to have a telepresence doctor, that you start to need that many people, you start needing a university.
We see in sort of human history and human archaeology, every time that human beings are cut off from one another or move to a smaller location, like apparently like when people moved to Tasmania and Tasmania, didn't have a land bridge to Australia, the kinds of technologies that they had decreased. They got less technologically advanced than what was happening in Australia at the time. And that's what you're going to see. As you said, you need neurosurgeons, you need cardiac specialists. Our modern society depends on this interconnected population of 7 billion people interacting and engaging and developing technologies and supporting each other. To have a completely separate, self-sufficient society is going to require both a tremendous amount of technology and certain shortcomings. It's just the reality.
And where this becomes super apparent is if you travel to remote places, and they don't even have to be that remote. If you go to a school in rural farming country where you're 4 hours drive from the nearest airport, you're not going to have people that have the same access to ideas.
Yeah.
And there are places in Alaska that a doctor visits once per week. Think of how spoiled we are when you get some sort of infection on a Saturday and you're like 8 p.m. on a Saturday going to the local urgent care. That's not an option in some places where I was listening to a story where they were talking about having to take a airplane to Juneau, get triaged in Juneau, and potentially flown to an even bigger city if there was something sufficiently wrong. This leads to people dying. Where I live, our local hospital can't handle most things.
Yeah,
and
same here.
And so they aeroflight you to the other side of St. Louis, and I have a friend who survived a dissected aorta because of a helicopter flight of 20 minutes.
Wow.
Now, if that helicopter flight had been any longer than that, he would have died.
Wow.
Now, you can't take a helicopter to a nearby city if you're on Mars. So you have to have the cardiac surgeon. You have to have the neurosurgeon. Or you don't have the quality of life.
Arjone asks, as we observe exoplanetary systems for longer and longer, will we find more solar systems that will look like ours around sun-like stars?
So I can't help but laugh because solar systems just keep surprising us. We have
less and less like ours.
It's sometimes I look at the stuff coming out of the exoplanet community and I'm like, universe, are you drunk? But because like planets just crop up in the craziest of places. It's like, why would you put a planet there? So I think the longer we look, we are either going to find that planets have a flat distribution of we're going to have 3 like this and 3 like this and 3 like this, or we're going to find that there is increased probability of certain alignments of where planets get stuck. But I don't know yet if we have enough information to start to guess which way it's going to settle out, because we're just starting to find the smaller worlds. And that's awesome. Like I've said before, we do science because we don't know all the answers and we want to.
From Age of Atheism, who is responsible in monitoring contamination issues when we send spacecraft to other worlds? Are the protocols the same for each country?
Theoretically, yes. Theoretically, this is stuff that comes down at like UN level decisions where there's like international committees who have figured out like Curiosity can't drive near the dark streaks on Mars.
Right.
Reality is we can't even keep our own commercial space companies from putting communication satellites in orbits that screw up Arecibo. So once you're in space, no one can stop you.
Yeah, enforcement is 9/10 of the law. That if the Chinese, who haven't, I think, signed the Outer Space Treaty, get a rover to the surface of Mars and they didn't clean it up, you know, what are you going to do? Zap it? Larry Beckham says, Star Strider, you need to write that book. Universe, are you drunk?
I need to have like a new blog as a starting point. I need to find more time to write.
It's a good title, though, for your book.
It's true.
Go home, Universe, you're drunk. All right, we should wrap this up. We're at the end of our hour.
Where would it go home to? You've now caused existential crisis.
You don't have to go home, but you can't stay here.
Okay.
Pamela, thank you as always. Big reminder to join the WSH crew, which is this chat down at the bottom. They're, of course, weekly space hangout crew. You can go to wshcrew.space, join the community, and participate in the chat, and also help be a producer on the shows that we do. So it's free. Just go do it.
And big shout out to everyone who is joining our patreons.com/astronomycast. You allow us to plan forward. We are actually getting ready to hire Susie as an employee at the Astronomical Society of the Pacific so that she can be responsible for making sure the two of us like keep our shit together. And I know it's hugely exciting to her to not have to submit invoices on a regular basis, and you're making that possible.
Yes.
And I've gotten several notices from PayPal saying so and so canceled their recurring donation. Words, they're hard. And I've consistently gone over and checked on Patreon and found those people there, and that makes my day. So thank you for that. Everyone who cancels their recurring donation and goes to Patreon will get a personal letter from me.
And you've been doing the office hours, right?
Yeah. So I've been doing office hours. We canceled them today because like this is the longest thing I've done in several days. Because like I said, I got sick, so I'm sitting here with my hot beverage, keeping myself vertical with no makeup on. And so far the brain is still working, but I'm skipping this week's office hours. I'm sorry. But yeah, I've been doing office hours most weeks, Fridays, and then when it's not on Fridays, on Sundays. We may do one on Sunday this weekend. I need to check the weather because we've been getting storms that turn off the power here.
Amazing. All right. Well, once again, thank you, everybody. Thanks, Pamela. We'll see you all next week.